Hello, my name is Craig Kennedy and I'm part of the KBC Network's global technical team. Today we're going to show you how easy it is to set up and use the KBC Network's ThruLink hardware VPN solution. While viewing this demonstration, please pay close attention to the following things. First, how simple it is to set up the actual ThruLink unit itself, and second, the quality of the live video transmission over a standard internet connection using the ThruLink. Viewing live video is completely different when compared to streaming a movie over the internet, for example. When you watch a movie, there is buffering involved, where the movie is downloaded into a buffer, and when the buffer reaches a specific size, it begins to play, constantly buffering new information all the time whilst playing, so it's not truly live. Live video is extremely sensitive to latency. For example, when you're in Los Angeles and you want to view a live feed from a camera in New York, there are no guarantees at all, and you're likely to experience jitter problems. Transmitting live CCTV video over the internet can be quite a challenge, but ThruLink implements unique technologies to optimize the live transmission so the live video quality can be exceptionally good and fluid in many cases, which you will see in the next demonstration. So here is the KBC Network's ThruLink. As you can see, it's a compact and rugged design, capable of operating in harsh temperature environments. So I'll just run through the external connectors now. Starting with the power, we have a standard 12 volt DC 2-pin screw terminal connector which includes reverse polarity protection. Then we have the LAN port. This is the VPN port. All traffic that flows through this port is fully encrypted at all times. You would connect one or more devices to this port via a switch. Then we have the WAN port. This port would be connected to an internet-enabled router or network. Next to this we have a primary LTE connector which uses a mini SMA connector. This would be for your antenna. And then we have a Wi-Fi connector, again using a mini SMA connector. On the front side there are 3 LED indicators. First we have the power LED. Then we have the connecting or connected LED which will flash whilst trying to connect and go solid when connected. And then we have the last LED which will periodically flash while checking the connection status to ensure it's still working. Then we have an auxiliary LTE connector. If your network supports diversity, you can use a second antenna for a better quality of service. And then finally the nano SIM slot. And there we have the external connectors of the ThruLink. So now I'm going to connect this ThruLink up starting with the WAN cable. This is the internet connected cable and it plugs into the WAN port. Then I'll connect my computer to the LAN port of the ThruLink. And finally I'll connect the power connector. Now we're not using a 4G connection for this demonstration. Instead we're using a standard ADSL router. ThruLink takes about 15 seconds to boot up, so I'll just get my laptop on and we'll zoom in on the screen and show you the configuration of the system. So now open up any browser. I'm using Edge. The default IP of ThruLink is 193.163.1.1. Now press enter and you'll be prompted to log in. The default user and password is admin. Once you get into the GUI, you're going to be prompted to change the password to something more complex. The new password has to be between 7 and 15 characters with at least one number and one special character to make it secure. Once you've saved this new password, click any link and you'll be told to log in again using the new password. The first thing you need to do is go to configuration and give the unit a unique hostname. All ThruLinks need a unique hostname. We're going to call this one KBC Networks Demo 100. You can ignore all other settings on this page for the time being. They aren't needed to get a system working. And click Save Update at the bottom. This will take a few seconds to save. Once it's saved, we can move on to Encryption Tunnel. So if you click Encryption Tunnel on the left menu. Initially, we aren't going to enable the VPN. We're going to set it to client mode. Then we're going to insert the pre-shared key, which is the same on all of your units for the network. Then we're going to enter the remote host name. So that's the name that you gave the server, and the remote connections. So this will be the public IP address of the server or the DNS address of the server. And then we're going to hit Save Update at the bottom. Once that's saved, click on Interfaces on the left, where we'll configure the physical connections on the ThruLink. By default, ThruLink's WAN port is enabled for DHCP, so it's going to be looking for an IP address from your network. So as this is just a demo, the IP address I'm going to use for the LAN port is 193.163.193.1. And the LAN port also has a DHCP option, which can issue IP addresses for your devices. Now click Save Update and it will ask you to do a full reboot for the system. Click OK and it will begin. The reboot will take approximately 15 seconds. And remember, you now need to change the IP address in the browser because you've changed the IP address on the ThruLink's LAN port. Once you change the IP address, hit enter and it should take you right back into the GUI again. So here we are, back into the system. You can see the host name. It's enabled but not connected. So let's go into the encryption tunnel again. Now click Enable to turn it on and hit Save Update at the bottom. Once saved, now click the System menu on the left. Here we can see the WAN configuration and the IP address we've been given by the network. We can also see here the LAN configuration and the IP address we assigned it. And we can see the unit itself is enabled and actively connected to the demonstration network. So now I'm going to show you some live video. I'm using Indigo Vision, but you can use any software. I've pre-programmed this with 2 cameras, so I'll just drag this one across to the window. I'll enable the statistics for the camera, and here we are looking at live video from Scotland. A pretty high resolution, but a much lower bitrate and 20 frames per second. There's not a lot of movement here, but we can zoom in on the washing line, for example, where you can see there is some motion in this image. This is a digital zoom, so it won't be the best quality. Or we can zoom in on these trees, and you can see it's pretty much real time. Okay, so let's pull in a PTZ dome camera now. It's only a small one, but it does give us control. And I'll shut down the Scotland camera and maximize the window for the PTZ camera so you can see it a little clearer. Exceptionally good quality, running 10 frames per second rather than the full 25. It's still 1080p and at around 1.4 megabits per second throughput. You can see just how good the quality is and just how fluid the video is when we pan the camera. And remember, this is over a standard ADSL connection, fully encrypted, that I could be accessing from anywhere in the world without any of the typical headaches associated with this type of connection. So there we have it. Live video from multiple locations over a public network, very simple to configure and get this level of quality.